So for section 3.2, we're going to look at measures of center. The first one we're going to look at is a mean. A lot of times we think of this word, we know the word average. So if you're already comfortable with that, that's fine. But in statistics, we do call it the mean. The average, normally people will tell me, well, we just take all the numbers and we add all of the numbers, add them all up, and then we divide by how many numbers there are. It'd be nice if we had a simpler way of writing that. Good news is we do. When we add all the numbers, we can use a symbol for that. It's this little, right there. That is called the summation notation. It's fun because it rhymes, right? And basically it just says add. That's what that means. Add, and I put x, add all the x, add all the values, and divide by how many numbers there are. That's n. N is our sample size. It's how many numbers there are. This is a much cleaner way of writing that. The the sample mean versus the population mean. The sample mean, we use the symbol X bar. Because it's from a sample, that makes this side a statistic. Sample statistic. The population, this is our sample mean. For the population, we use mu. It's kind of like a cursive M. I've seen people call it like a cursive U, but I think of it looks more like an M to me. That is our population mean. This would be if I could run a census and get the information from the population, or if we run a large enough sample, we can actually infer, we can make statements about what we believe the true population mean to be. Since it's from the population, that makes this a parameter. We'll also have the same thing with sample and population when we're dealing with standard deviation. I'll deal with that later. The round-off rule, all I want to encourage you to do is carry as many decimals as possible. The idea of this, and this is a life skill that actually applies outside of this math class, when you're doing anything, you should have an attention to precision. How will I do that? Well, I'm going to write down numbers and keep track of them as I go, but as much as possible, I want to keep all the numbers inside the calculator. And the reason I want to do that is because as I round off numbers, at the end I could have numbers that are off. Now what I do on the test is I give you a little bit of wiggle room. Say like the answer, like for instance on the previous test that you just took, you should have had a question where you put a percent. I gave a wiggle room about 1 or 2% because, depending on how you read the graph, you might disagree with me by 1 or 2%. So I give you some wiggle room with that. I'll do the same thing with the answers a lot of times if I'm asking for a value, there's a little bit of wiggle room I'll give. The homework will not. The homework will require that you keep it as precise as possible. So write down a bunch of decimals or start keeping it inside the calculator. Okay. The median, this little symbol I don't use actually, and I don't remember it being in the book either. I'm going to just use a capital M, not cursive. And that's what I'll use for median. It's the middle value. The key on this is if I wanted to find the median, let's say I was finding the median height of a person in this classroom, I could look around at everyone in the classroom and just pick the person in the middle. And that wouldn't make sense because the person in the middle may not actually be the middle height. What do we have to do first? I'd have everyone stand up and put them all in order. You can't just choose the number that's right in the middle. You actually have to have the numbers in order first, and then we find the middle value. What if there's two people or two numbers in the middle? You take the average of their heights, okay? So there's a couple ways of doing this. If there's an odd n, if there's an odd sample size, then to get that middle number, you can just do n plus 1 over 2. And that number will be the middle number. For instance, if there were 15 numbers, what number would be in the middle? Well, 15 plus 1 divided by 2, the 8th number would be right in the middle. That should sort of make sense. If you think about the 8th number, it has 7 numbers before it, and it would have 7 numbers after it. So the 8th number would be in the middle. If you have an even n, an even sample size, this gets a little more complicated. What you have to do is take n divided by 2 plus the next number and divide both those by 2. Now this seems complicated. Trust me, it's not that bad. I'll show you. But basically it's just the average of the two numbers in the middle. So let's say there were 16 numbers. Okay? Well, 16 divided by 2 would be the 8th number again. But this time the 8th number is not in the middle. There's actually two numbers in the middle. It'd be the 8th number plus the 9th number divided by 2. We're going to average those two. We're going to find what's in the middle of the 8th and the 9th number. We'll do an example where we'll see this a little more visually. But for those of you who love formulas, there you go. Alright, where are we at? The mode is the most common number. Something I like to do with this, I think is interesting, if you ever watch CSI shows and you have those, serial killers, they use this word on a phrase that they use. They'll talk about somebody's MO. And what an MO is Latin, and I'm not going to get it exactly right, but it's like modus operandum. And it's like, well, that's kind of their tag. It's what they do when they kill these people. They have a most common way, or they have kind of a tell, so you know it's them. This has the same root, and it's a little less creepy and scary, but mode is just the most common thing that you see. So if you see it frequently, we get the word mode. I think things like this are interesting. If that scared you, just ignore it. We'll keep going. The mid-range, I take the maximum plus the minimum and I divide by 2. This is a measure of center. So it's going to be in the middle of the highest and the lowest number, so it's still going to be a measure of center. These last two are not tested. I believe I have one of the top ones I know I have one in the notes, and I think I left one in the homework just to see it. But it's harder than it needs to be, and I don't really see a situation where it's terribly applicable. But I do want to cover it anyway, just in case it has some applications I don't know about. But don't stress about these yet. Skewed distributions. The key on this one, okay, we should know what skewed distributions are. But here's the idea. If I have a normal distribution, we should know that right in the middle, we have two things. The mean and the median. They line up perfectly if it is normal. If we get a distribution that is skewed, if it is skewed, to the right, that's a better picture, okay? So what happens? Well, they both potentially move, but the one that actually factors in the highest numbers is the mean. So the median gets pulled a little bit to the right, and the mean gets pulled further. On the flip side, I'll have to draw this one smaller. I should have planned ahead. If I have a distribution that's skewed to the left, well, instead of both being in the center, the median gets slightly pulled to the left, and the mean gets pulled further away. What do? We call this resistance. See, the median is resistant. It doesn't really move much, and the mean is non-resistant to outliers. It gets pulled by extreme values. It gets pulled much further away than the median does. On this side, the median is resistant. It doesn't get pulled. It doesn't get pulled away. The mean is non-resistant to outliers. The idea is it would get pulled towards the skewness, okay? And they do have this stated earlier. I kind of skirted over it. But if I look at mean, the mean is sensitive to extreme values. It's sensitive to outliers, or not resistant to outliers. The median is not affected by extreme values. That means it is resistant to outliers. Okay. Here's a list of numbers. There's some instructions here for those of you who have the TI-83 and 84. I'm going to be showing you how to do this with the Inspire. I will encourage you, though, that you do need to make sure you can do this by hand. So, for instance, if I want to do the mean, you should be able to find the mean of these numbers. The mean is where I take all the numbers and we add them all up. And divide by, how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there are 11 numbers. So take a second, add those up, and let's see what you get. So I added those numbers and I got 1017 divided by 11. So we got an average of 92.455. That would be the sample mean. Now to do the median, keep in mind I'm not just going to pick the number right in the middle. What I need to do is I have to put these numbers in order. So let me scoot back up so I can see them. And it looks like our lowest number I see up there is 82. And then we have 87. Then we have, looks like 92. And 92 occurs twice, so we'll write it twice. Then we have 93. And we have 94. We have 95. 98. Nope, we have a 96. The 98 shows up twice. And I think that's it. Did I miss a number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I sure did. Which one did I miss? 82, 87, 90. Well then, 90, 2 92s, 93, 94, 95, and 96, and 2 98s. Double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, feeling good about that, okay? So what we're going to do now is to get the median, I'm looking for the number in the middle. I can use the formula, but I can also kind of count my way towards the middle. I can go 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, ding, ding, ding. We got a number right in the middle. So our median is 93. If you like formulas, n is 11. 11 plus 1 over 2 would be the sixth number. 1, 2, 3, 4, 5, the sixth number. The mode, what is the most common number? Well, we saw 92 twice and we saw 98 twice. So what that means is that there are two modes, 92 and 98. If it has two modes, we just call that bimodal. It has more than one mode. The mid-range, we take the lowest number, 82. I have to clean that up, sorry. Plus the highest number, 98. All divided by 2. I think that's 180 divided by 2, which is 90. And notice that is still a measure of the center. It's a little off from the other ones, but it's in the middle of the highest and the lowest number. So we have our median, we have our mean, we have our mid-range. All measures of center. What if I added another 98 at the end? Okay, so now it's 98 plus 92 plus 95 plus 87 plus 96 plus 90 plus 92 plus 82 plus 93 plus 98 plus 94 plus our new number 98, all divided by, now there's not 11 numbers, now there are 12. Of course, I could just take the 1017, add 98 to it, so I think that is 1115 divided by 12. Double check that, and let's see what that mean is. So where's my calculator? Right there. Let's go ahead and do 1115 divided by 12, about 92.917. Not helpful. 92.917. So we added a higher number. What did that do? Well, it pulled the mean a little higher. What if we add that to the median? Well, now we have 82, 87, 90, 92, 92, 93, 94, 95, 96, 98, 98, and we added a 98. Well, what does that do when there are 12 numbers? Well, if I count my way towards the middle, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, I end up with two numbers in the middle, 93 and 94. So our median will be the average of those two. What number's in the middle of 93 and 94? Our median is just 93.5. What is that? 93 plus 94 over 2. Okay? That would be the middle number. If you like the formulas, what is it? N was 12. 12 divided by 2 is the sixth number. So we would average the sixth number plus the seventh number and divide by 2. Not my favorite, but it does work. What happens? Notice that moved up a little bit too, because we added a number at the end. Okay? What would happen to the mode? Well, now there are 3 98s, so now our mode would just be 98. The mid-range, the minimum stayed the same, the maximum stayed the same, so the mid-range stayed the same. Okay? I want to add, actually we'll get back to this later. I'm going to come back to this data set. I encouraged you, if you haven't done so, take a second, type these numbers into a list, because we're going to be looking at those, the original numbers, not with the extra 98 at the end. So type in these original 11 numbers, and we're going to kind of look at how the calculator does that in a minute. Let's go ahead and do something scarier first. This, approximate the mean from the following frequency distribution. See, I know that there's one number in here, and it could range from 96.5 to 96.8. I don't know what number it is. It could be on the low end, the high end. So what would be a nice middle number, right? A nice middle number that would represent what the number could be. Well, that would be the midpoint. What is the midpoint? Directly in the middle of this range, of this class. So it's the 96.5 plus 96.8 divided by 2. That should be 96.65. What's the midpoint of the next one? 96.9 plus 97.2, all divided by 2, or about 97.05. And we could keep going. I want all these midpoints. And this is going to be in the homework. I'm not going to test you on this. So let's see, 97.45, 97.85, 98.25, 98.65, 99.05, and 99.45. So what we're doing is we're basically saying we don't know. See, like this one has 22 numbers. I don't know. Those could be 22 98s for all I know. I don't know. But we say whatever they are, I'm going to just choose the number that's in the middle, and we're going to call them all. This is a way of approximating the mean if I don't have the original data. What do we do now? We take each of those midpoints and we multiply them by their frequency. So it'll be 96.65 times 1, this one times 8, times 14, times 22, times 19, times 32, times 6, times 4. Alright, I'll do the easy one. 96.65 times 1. Here's where things get tricky. 97.05 times 8. Double check it. About 776.4. That is not helping. Okay. 97.45 times 14. 1364.3. 97.85 times 22. 2152.7. 98.25 times 19. 98.25 times, is it 17? I think. What was it? 19. 1866.75. 98.65 times 32. 3156.8. 99.05 times 6. What was that? 99.05. It was times 6. 594.3. And 99.45 times 4. Where are we at? Right there. And 397.8. Okay, so how are we going to get a mean from this? Well, I still have to take all these numbers and I have to add them up. So I add up the midpoint times the frequency. I'm going to take these 1, 2, 3, 4, 5, 6, 7, 8 numbers and add them. So I'm going to cheat a little bit. What was our top number? That's our first number. Plus. Our second number? No. Should have been. Did I get the times 1? Gosh, I didn't do that. Alright, I missed the first number. What was our first number? The 96.65, and then the 777. 96.65. That's what happens when I try to save time. 96.65 plus, there we go. So I got the 1364. The next number was the 2152. Get the plus sign. Plus, after 2152, was the 1866. Plus, 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 and I hope this is right. How about 10405.7? That is not the average. Our numbers range from 96 to 99, so that doesn't make sense. What we do is we divide this by n. What is n? Well, the sample size. It is the summation of the frequencies. Add up all the frequencies, and that's going to give us our sample size. I'm going to try to just add these real quick. I don't want to go back and forth. Let's look at 10, 42, 50, 63, 85, 9. Don't want to wait. Double check the other way. 9, 23, 55, 74. On, off. 106. Yeah. Alright, one more time. 10, 42, 50, 61, 73, 80, 91. No way, this is 100. 18. Alright, forget this. That's a cheat. Let me erase that. Okay. Where's my calculator? Add a sheet. Alright, what is the sum of everything in A? 106. There we go. Look, I can add. Just got to use the technology. So 10405.7 divided by 106, and we got a mean of 98.167. This is a way of approximating. Like I said, I'm not going to test you on this, but it is kind of interesting because look, doesn't it make sense that the average would be about 98.1? I mean, the numbers are some up here and some down here, but isn't that like around the middle? So this is just a way of approximating the mean. Okay? Two more things and then we're done. First is this. Do you see this list? Okay? I asked you to type in that list because I don't want you to have to calculate the mean and the mode and all this by hand. So let's look here. You should have typed in the list. I did. And I did it here in 1.1. Okay? And I even titled it, I'll hardcore that way. These were the minutes that they gave us. The original without the extra 98. So there's 11 numbers. Okay? A couple things that would help. If I have a big list of numbers and I do need the median, don't forget we can sort them. It's not really going to matter this time, but I could sort them. What I do want to show you, though, is in menu, we are going to be able to collect some statistics on this data. They say statistics because they're assuming this is sample data. Okay? In there, we can get some calculations under stat calculations. This would be something you'd want to write down. So statistics, stat calculations, and one variable statistics. So let's write that down. That was, for those of you using my Inspires, menu, statistics, double check, what is it? Statistics, menu statistics, stat calculations, and then one variable statistics. Okay? And, I mean, you're going to do this enough where you should be able to find that and run it, but if you, like, when I took this course a long time ago with the 83, 84, and I had to memorize all these different commands, I put those on my note card. And so that's something you could do. You could write this down. If I want to know any of that data, this is what we're going to do. Okay. So one variable statistics on one list. The data is in A. If it was in B, I'd need to change that to B, whatever it is. Okay? Don't mess with anything else. Put the results somewhere off. So since I have all my data A and A, the results are in B. What does this do for me? Is that the same mean we calculated? Yep. That's the summation we got. There's some more information down here if you scroll down. Notice there's the median. There's the min, and there's the max. So this is going to give you a lot of information really quickly. So get used to using this. Okay? I have one more thing I'd like to do. Okay, let's go ahead and clear both of these. Clear them out. And I would like to introduce one more topic with you. Okay, so with this set of data, and I do want you to put this on a separate sheet of paper, we're going to calculate the standard deviation. We know the mean was, where's my pen? One second. We know the mean was 92.45. What a standard deviation is basically how far off the average, how far off the numbers are from some standard. When you deviate from a path, you go away from the path. Okay? So standard deviation is like the average deviation the numbers have from the mean. That sounds confusing. It's because it's the average deviation from the average. It's like, okay. But what do we do first? Well, we find out how far are each number off from the mean, 92.45. Well, how would I do that? I would take each number and I would minus 92.45. Then 92 minus 92.45. Then 95 minus 92.45. Now, I don't want to keep doing all these by hand. That we could, but so this one would be what, 5.55. This one would be negative 0.45. This one would be positive 2.55, so on and so forth. I'd like to keep this in my calculator if possible. So since we have all this, in our calculator, what I'm going to do is I'm going to go over here to the equal sign, and I'm going to say take everything in A and subtract what was our mean, 92.45. Are those the same numbers we were getting? Well, they are, but they're not in order, aren't they? Okay, so did I put these in order? No? Interesting. Well, that's not helpful. So I guess I do have these in order. That's what. All right, I'm going to undo that real quick, just so that my tables match. I give up. Okay. $98, $92, $95. It'll be quicker just to type in the numbers. $87, $96. $90, $92. $82, $93. And, oops, well, that was cool. 82, 93, 98, 94. 11 numbers. And where were we? Every number in A minus the mean, 92.45. Let's write those down. So the next one would be negative 5.55. Just double check, make sure I'm not crazy. 5.45. Okay. The next one would be 3.55, negative 2.45, negative 0.45, negative 10.45, positive 0.55, just only have two left, 5.55 and 1.55. So I want the average deviation from the mean. So this tells me how far each number deviated, both positive and negative, above and below. How do I get an average? Well, I would take all these numbers and I could add them up. 5.55 plus 0.45 plus 2.5. Adding all those up, I'm going to cheat. And I'm going to say right here, I'm just going to do, what is the sum of everything in B? Well, that's weird, because in theory, this should be 0. But what we just got was 0.05. What is that? Why are we off? Well, it's called round-off error. See, we rounded each of these to 2 decimal places. So look, at the end, we were off by 2 decimal places. Several of them got rounded up enough so that we were off by 5/100ths. Okay? So in theory, if I kept all this in the calculator, that should have been 0. By rounding off, we're off by 0.05 at this point. But the problem is this. If I wanted the average deviation and they add up to 0, this didn't work. This didn't fix our problem. So what do we need to do? Well, I can't add numbers that are positive and negative that add up to 0. So we need to make these positive. Logically in algebra, we say one easy way to make these numbers positive is if I just did absolute value. The problem is everything we do, we have to be able to undo. And you can't undo absolute value. So what did the statisticians do when they kind of came up with this? They said, take each of these numbers and square them. What will that do? The positive numbers will stay positives. The negatives will become positives. Then we'll undo that in a minute. So let's go to C. I'm going to get rid of this. And C is going to be everything in B. We need to make them all positive, which means we're going to square them. Let's write those down. 30.8. 0.2025. Now I'm just writing these down. Notice I'm keeping it in my calculator, 6.5025. So that's going to help with my precision. 29.7. 12.6. 6.2025. What is that? 109.2. 0.3025. 30.8 and 2.4. Now that I've made them all positive, I can get an average deviation from the mean. We took how much they deviated, we squared them to make them all positive. So now I can go down here and add all of these numbers. Once again, I'm going to cheat. I'm going to leave it in my calculator. And I'm just going to say, what is the sum of everything in where? Well, in C. Oop, need my brackets. 228.728. But that's not an average. What we have to do is we have to divide when I do an average. I add them all and I divide by, how many numbers were there? They're like, well, 11. So I divide it by 10. Like, what the heck? I just divide it by 10. Well, we don't divide this by n. When I'm doing the sample size, we divide it by n minus 1. Why? Here's the only logical reason. I mean, the short answer is because it's more accurate. But one of the reasons why we divide by n minus 1, look at what we did. The first thing we did is we subtracted the mean from each of these numbers. What if the mean was one of the numbers? What if 92.45 was one of the numbers? That number would have disappeared. So to account for that, by the subtracting, we find it's more accurate to divide by 1 less, because we took a number away. I don't know if that's the best answer, that's just the best I've heard. So this ends up being 22.8728. That is not the standard deviation. That doesn't make any sense. Look, the numbers don't deviate from 92. They don't deviate by 22. The highest was 98. The lowest was 80. That doesn't make any sense. But don't forget, what did we do? We squared the numbers. So we have to undo that at the end. To get the standard deviation, to get S, we take everything we just did, adding them up, dividing it by n minus 1, and we square root it. So what is the square root of that? What was it? The square root of 22.8728, about 4.78255. This is the standard deviation. On average, the numbers deviate from the mean by about 4 to 5. So 92, the highest was 98, the lowest was 82. They deviate by about 4 to 5 on average from the mean. Dang, that sucks. Like, I don't want to have to do this every time. I'm wanting to introduce this. Trust me, I know that was scary, but I need you to understand this because we're going to build on it. But look, wouldn't it be nice if this calculator could do that for us really quickly? Good news, it can. You've done this before. Menu, statistics, calculations, one variable statistics. Make sure we're running it on list A. And I'm putting the results way over in F to not get over what I just typed in. But look, do you see this X? This S right here? 4.78254. 4.78. How far off were we? 255. We were off a little bit. Okay, some round off error. That is how we're going to calculate standard deviation with the technology. Why are we doing it by hand? Because I need you to understand what it means.